Okay, yet another factor that affects acidity is hybridization. Hybridization this is a less common effect. But for completeness, we are going to cover it. So let's look briefly at hybridization. Remember sp3 hybrids. Each of these sp3 hybrids has 75% p character. It's 3 parts p and 1 part s, and 25% s. sp2 would be about 67% p character, 33% s, and then sp is going to be 50% p, 50% s. So as it turns out, if you look at these orbitals, the p orbitals are more elongated. So the more p character you have, the more elongation of the orbital. And the more s character kind of gives you a shorter orbital. So greater p character translates into greater elongation. And that's kind of the theme here as we talk about this, how this affects acidity. So let's look at some examples. Let's look at ethane. Ethane is a super weak acid. It would never be deprotonated by water, but we're doing everything with water, so I'll keep on doing it with water. Water can deprotonate this, and we will get a conjugate base. And the other molecules I want to look at are ethene, and ethene, when deprotonated, will form this conjugate base plus H3O plus. And then lastly, we'll look at acetylene or ethine. And again, we go through this equilibrium, we form a new carbanion. In this case, it's that particular carbanion plus H2O plus, 3O plus. Now, all these carbon species have different pKa's. Ethane is a pKa of around 50, ethene is around 35 to 40, and acetylene or ethine is around 25. So ethine is the most acidic, which tells you that its conjugate base must be the least acidic. And what's changing through all these trends is hybridization. So this is an sp hybridized anion. This is sp2. And for deprotonation of ethane, we form an sp3 hybridized anion. The explanation that people give is that as you look at these anions, this sp hybridized lone pair is actually pretty short and squat. It's short because it has high S character. Remember, this is 50% P, 50% S. So therefore, this ought to be the shortest orbital. This orbital gets a little longer, and this gets even longer still. So that electron density for this top anion is held pretty far away from the nucleus. Electrons want to be close to the nucleus. This electron density is less happy. Less happy means more reactive. More reactive how? Well, this is a conjugate base. So this is going to be the most basic. And I see a mistake on here. Least basic, that should be. This is the most basic, and as you change the hybridization to have more and more S character relative to P character, they get more stable, less basic. And on the flip side, the least basic anion is the most acidic. So this is an example where people use hybridization to explain changes in acidity. We won't encounter this too often because in general we're going to deal with a lot of sp3 hybridization. Hybridization isn't going to change that much for us, but when it does, it can have a big impact on acidity.